Next about the transformer only. If, as you know, transformer works on the Faraday's law of electromagnetic, that is E equal to minus n phi by dt, right? So in this case, we should know that how much EMF will induce. If you are giving supply to the primary winding and automatic EMF is in primary winding only, then in that case, EMF will induced, and that kind of EMF is known as self-induced EMF. Okay, and if you are giving supply to the primary winding and automatically EMF is in secondary winding, that is technically known as fully induced EMF, right? So suppose if you have money and you are buying gift for yourself, right? That means that is your self love, correct? So primary to primary self. And if you are having money and you are buying gift for your girlfriend, suppose, then that is your mutual love, right? So primary to secondary, that is, got it? Now in the next case, we should know now that how much EMF is induced in primary and how much. So for that we'll have particular formula, that is E1 is equal to 0.44 N1 F phi m. For E2 it will be 4.44 N2 F phi m, where E1 is the self-induced EMF, N1 is the number of turns in the primary side, right? F is the frequency and phi m is the maximum flux. So if we are inducing the voltage in the primary, even that depends on the number of turns N1, and if we want to calculate it, then that depends on the number of turns N2, right? And if I'll divide the complete formula, then in that case all the terms would be cancelled out and rest of the term would be 1 by E is equal to N1 by N2, correct? So similarly we can write down like V1 by V2 is equal to, current is always it, means as I told you if voltage is increasing then current must decrease. So current would be I2 by I1 is equal to, where K is the turn ratio. So you should remember this formula, that they can ask you that what is the turn ratio formula in the case of transformer, or maybe they'll give you any simple numerical based on. Yeah. Next we'll study about the losses in transformer. Losses, how can we get, like as you just studied in the transformer, we have two materials, like, right? One is the primary winding, another one is the secondary winding, correct? So the winding which is made up of which material? Generally wire is made up of which material? Copper material. It would be a copper loss, and the material which we are using for the transformer, that material is generally iron material, right? You have seen a transformer outside your campus or maybe outside during like road, right? So that transformer material is of iron material, so losses iron losses. Okay, in some of the book you will get core a word, so core material, like uh, the core word is used to which material you are using. Now iron losses and is further divided into category. One is the hysteresis losses and another one is the eddy current losses. Got it? So next we'll have the formula for copper loss. Copper loss formula is I square R. Eddy current losses and hysteresis losses formula you will get directly from your handbook. Okay. So now the thing is, how can we reduce hysteresis losses and how can we reduce eddy current losses? If instead of iron material we will use silicon steel material. Okay. Instead of using iron material, we will use silicon steel material. Then in that case, hysteresis losses will get reduced. And how will we reduce eddy current losses? By using lamination. See what is exactly the lamination. You are having an iron like this, cut the iron material into thin slices like your bread, and you combine it. That would be the form of lamination. So if you do it by the lamination, that will eddy current losses. Okay. Next thing, most important, that is efficiency of transform. Yeah. Now suppose if I'll ask you, like I gave you 5 questions in your homework and you did only 4 out of them. So how much would be your efficiency in that case? Can you tell me? Efficiency 80%. So how did you calculate? 4 by 5 into 100 or 5 by 4? 4 by 5 into 100 now, then only you will get 80%, right? So suppose I give 5 questions, that is your input, correct? And from that you only be able to do 4 questions, that is your output, right? Plus 1 question is the loss. Can we say that? Efficiency is denoted by, you have done 4 by 5, means you are doing output divided by input. Can we say that efficiency is always output power divided by the input power, and efficiency is always in the percentage multiplied by 100. Okay, clear? Efficiency is how much? As you know, this will become a formula that input is equal to output plus losses. What does that mean? Never will give in anything, then that would be converted into output, plus definitely there will be some losses. Suppose you are using a fan, right? In fan you are giving input, that is electrical energy, and it is converted into mechanical energy, it starts rotating, that is output, and some of the losses will be there. So can we say that input power is equal to output power plus losses? Hmm? So output power divided by input, will write down output power plus losses multiplied by 100, right? What is the formula for the output power? Output is on the second, that would be I2 cos phi 2 divided by V I2 cos phi 2, plus there are losses, the iron losses and the copper losses multiplied by 100. This is the final formula we'll get for the efficiency. Maybe they'll ask you a simple numerical or they'll ask you the efficiency of the transform. Got it?